Welcome, good afternoon, good morning, whenever it is you're tuning in. If you missed this class, we talked about two different types of derivatives. We talked about this function e to the x. I'll just write y equals e to the x, the exponential function. Remember that e is actually a number, as pi is a number. We just use a symbol or a letter in this case to designate that number because it's really ugly and has a really long decimal. It's 2.71 something, something, something. So we just use e. Anyways, it's the exponential function. And then natural log, its inverse. Remember that these are inverses of each other. That log, this is actually log with a base of e. Anyways, that's natural log of x is going to be what we're going to be talking about in addition. Now we'll start with the exponential function. The exponential function actually has a very strange derivative. To take the derivative of an exponential function, and once again, exponential because the exponent is actually x and it has the e there. The derivative is also e to the x power. Strange, but true. So this should actually be one of our easiest derivatives that we have to find. So what we might do is we might combo this derivative with other rules that we have. So let's find a quick example where I might need this information. Let's say if f of x equals 2x e to the x, find f prime of x. Well, we can see here that what we've actually have are two functions being multiplied together. I have a 2x and an e to the x. And that those two things are being multiplied together signifies to me that we're going to be using the product rule. So I'm going to use some old school product rule. And this was, I believe, 8.11 or 8.12. You can go see that. And when I did the product rule, we used this formula, y prime equals u prime v plus uv prime. Okay, and we set up our table. And our u would be 2x, our u prime, the derivative is 2, v is e to the x. And what we just found out here is that if I take the derivative of e to the x, it stays e to the x. So I'm showing you how this might come up several times. And now that I have this, we can actually put this together in our product rule, which also works in this order. And what I would now have for f prime of x is, let's see, 2 times e to the x plus, because that's what our product rule tells us, 2x e to the x. All right, and there's our derivative, right? Using exponential functions derivatives and the product rule in this case is what I needed because those two things were being multiplied together. Now we could still find the slope of something like this by plugging in a number. If I wanted to find the slope of f of x at 2, I would first find f prime and then I would plug in 2 to that derivative. But I want to go on now to natural log functions. Natural log work a little bit differently. Natural log, the derivative, is 1 over x. Oops, kind of weird little, what the heck that is, 1 over x. And we might see this come up from time to time, or we might see something a little bit more complicated. Instead of it just being a regular x in there, we might see something like ln to some function u, or maybe the inside isn't just x, but it's like x plus 1, or 3x minus 5, or x squared plus 4x minus 100. I don't know, but it's its own little function. To find the derivative when the inside of the parentheses, the argument of our natural log, is something else, we keep that inside the same, and then keep that inside as the denominator, and then we multiply times the derivative of whatever that inside is. This is the one that we're going to be using more frequently, and that rule still applies to ln of x, because if you think about it, that would be 1 over x, the inside, times the derivative of x, which is 1. And 1 over x times 1 is 1 over x. So that derivative rule still works regardless. So this is the one that I want to keep. All right, this is me building a picture frame for it. So let's do an example of that. Let's say if g of x equals ln of, I don't know, 2x to the 5th. Let's find g prime of x. So let's use our rule here. And this is where I don't need to set up a whole table because we know that for our rule, we really just need to identify u, which is right here inside. Okay, so let's just go over to the side. U is 2x to the 5th. And according to this rule, not only need u, I'll need u prime. And I know that u prime, this is what I'm going to use the power rule. The 5 comes down with the 2 to make it 10. And then, of course, I always subtract the power, so that becomes 10x to the 4th. So this is everything I now need to now find my derivative. So when I take my derivative, let's see. I'm going to start with 1 over u, or 1 over whatever was inside, 2x to the 5th, times u prime, which was the derivative of the inside, 10x to the 4th. So if I do those two things, I have what I need, except what you should do here is really simplify this a little bit more. It's a fraction that I can multiply together. Think of that 10x to the 4th as 10x to the 4th over 1. I'm not going to include that 1 and ugly it up, but just think about how I'd multiply across the top. And then 2x to the 5th over 1, that would be multiplied across the bottom, so it's going to say 2x to the 5th. And then, of course, I could still reduce this, because think about dividing things. 10 divided by 2 is 5. And then x to the 4th and x to the 5th, there's going to be some canceling out. Think about there's 4 on top, 5 on bottom. I could subtract 4 minus 5 to get -1 and then put that on the bottom because it's a negative. Or I could just think about it this way. The 4 on top are going to cancel out with 4 on bottom, but I'm still left with 1. Okay. So I can think about that as canceling and be remaining with 5 over x. That would be the best representation of my derivative of a natural log. So how did I get here? I thought about my formula, since it was natural log. I identified u, right? There it is. So u goes in that bottom. And then I identified what would u prime be? The derivative of u. I did that work off to the side. I identified that. And then I multiplied those two things. And remember that that 10x to the 4th is its own fraction over 1, and that 2x to the 5th was on the bottom. So I put those two things kind of together in that way. And then I really just reduced. 10 divided by 2 is 5, and x to the 4th divided by x to the 5th is really 1 over x, or I have an x remaining on the bottom. So that would be my final answer. So I have natural logs derivatives, and I have exponential function derivatives. Both of them are fairly simple if you have these examples and you have these formulas in front of you. You'll have to practice those and do those on the quiz. Good luck to you.